Okay. Now we are live, at least on YouTube. Cool. There's a little bit of delay though. I think that's on purpose. Should we go live, like fully live? Okay, let's go. Oh, I think that looks good. Let's wait until 12 p.m. Central European, and then we can kick things off.
Sure.
Cool. Do you want to show the preview slide or the preview results in synera, so people can see what we're actually talking about today?
Should be able to see now.
Mm-hmm. Yeah.
How's my audio input, Jousef?
Yeah, perfect. Sounds really good. All right. We have a couple more minutes. We'll wait for people to come in. 77 people are watching right now. Really cool. Number is rising. 80 people, 84. Okay, I can at least see the screenshot on YouTube, but for some reason not on LinkedIn yet. Let me check. And for everyone attending via LinkedIn, you can also check out the YouTube link in the chat. So there you can see the screenshot from Akil in the preview results. I think it works now on LinkedIn. Okay, ladies and gentlemen, we'll kick things off in 5 minutes on YouTube as well as on LinkedIn. 150 people are live now on LinkedIn and around 15 on YouTube.
Cool. Seems like it's an interesting topic. Huh?
Definitely. Yeah. I think we can get started in like 2 minutes. Okay.
Mm-hmm.
We just joined a little bit earlier, ladies and gentlemen, because it's the first deep dive session and we didn't know if things are going to work out. So that's that. All right. I think there 1 more minute to go. But then for everyone joining already, quick introduction. So this is going to be the first deep dive session of a series of deep dive sessions. And I'm very honored to have Akhil Mora, a friend and a guy from, a colleague, I would call it, from Synera on the show today. We'll talk about FEA workflows or building FEA workflows in literally minutes using a low code approach. Where we'll talk primarily about process automation for mechanical engineers. So I think with that short intro, Akhil, maybe introduce yourself and let us know what you will be talking about today.
Yeah, thanks, Jousef, for the invitation. Really glad to be here today on live. So, quick intro to myself, Akhil Mora. I'm a mechanical engineer, basically. So, all my past few years worked on structural mechanics, numerical methods, and my curiosity for automation of the product development, especially for mechanical engineering and employing new technologies like AI, machine learning, as one of the interesting things for me. So today I will present how we can develop simulation workflows, which is finite element analysis using the low code approach in Synera. So we will see how one can start with, from scratch and then build the workflow as we go, and how it enables engineers to automate.
Amazing. So maybe let's take it away with a quick introduction to Sonoro. So what are you guys actually doing?
So we are building a low-code automation platform for engineers, and one of the areas that we will present today is FEM process automation. Usually in the product development, as we see, there are various steps starting from the initial requirements to developing a product. Of course, the digital development is the major key here, because one cannot simply create a part or a geometry or any vehicle and then test it. Of course, one has to go through this digital development process, where it involves multiple softwares, tools, and the experts. So how these various challenges one faces in this digital development process, switching between the tools, how the interoperability situation challenges the engineers today. That's the major problem what we are trying to solve today to accelerate this product development. So what are the sorry, what are the different approaches one trying to do in the market is to automate with the tools. Within the tools, let's say it can be a simulation like ANSYS, Abacus, or within a CAD environment like CAD, SolidWorks, or there are also programming languages like the modern programming language like Python to connect and automate this process. But usually it's not so easy because it's one has to be an expert to understand such programming language or to understand how a script has been generated or the automated approach. So what we do is, okay, we thought we should develop a programming language for engineers which should be easy to use, but it should also be much more powerful uh, today to automate this development process. So later today, we will jump into this FEM simulation, how we can build in minutes with this low code approach, and how one can easily drag and drop certain operations to develop a workflow. So that is a major idea to automate and accelerate the development process. So that's a quick intro to what we are doing here at Synera.
Really good. Once you switch over to synera, like the program itself, make sure you zoom in as much as you can, Akil, because I think people see three screens, and you really have to zoom close to see what's going on and what's happening.
Definitely.
Perfect.
So I think we can jump directly into the software now and start with a simple example first, and then later I jump how we can build simulation workflows in minutes. So this is our software Synera. It's a visual programming environment. What you see, this is the canvas where all this magic happens, where we build this low code workflows. And on the right is a viewer similar to any CAD environment or any simulation environment where you can visualize geometries, meshes, and yeah, FE results, things like that. So how it works is basically uh, these features called as nodes, what we call them nodes in the software. Each node has an input and an output, but certain nodes doesn't have an input. This is where we give the input, and few nodes based on the input, it gives us the output. So here we get an output, and one node can be connected to another node using a simple cable like this. And depending on the functionality of a node, it gives us the output. So here it's a simple multiplication. Of course, we will jump into the FEM process itself slowly, but let us try to understand this basics of low code before we jump into a complicated simulation case. And then few nodes together make like a parametric workflow. So here I will build a simple cylinder first, and then I will explain this low code approach. And then now, so here you see based on the node itself, the type of output would change. So here it was a number, but in this case, it's a geometrical entity here, which is a curve. And then one can, create a surface. And here, this is what you see now. It's called a radial menu. So as I keep using my software Synera, it will suggest the most relevant features for me downstream my application or the workflow building. And here you see to create a solid body out of this surface, one also needs to give what is the length it should be and in what direction it should extrude. So one can also build workflows in the reverse direction. So now I will give the direction in which it should create a cylinder and how much should be the length of this. So here we built a simple parametric cylinder, and whatever the changes that we make, that would be reflected live in the viewer, what you see here. So how it differs from a traditional approach of, let's say, CAD in this case is basically the whole workflow is driven by certain parameters, and one simply has to change this parameter and doesn't care about what's being developed here, usually by an expert, and then make use of this workflow in different projects. So what I can do is I can simply copy this workflow and then paste it to a different project. That makes it to recycle the projects. And here one can also simply include new changes, such as, let's say, I want to change the cross section from a circle to a polygon. So I can simply switch like one cable here, and then it will update the output. So that is the approach of low code behind. So we are basically building like a simple program here, an algorithm or a workflow without actually programming and making use of this simple functionality. So that's how this low code approach works. So before, now we can jump into the FEM use case itself. So for all the engineers watching there, let's do like a simple static analysis of a given geometry and walk through these different stages of FEM analysis. So how it usually works, the FEM simulation is basically one starts with importing a geometry. Of course, one can also build geometries here or also import geometries that has been developed in a different CAD environment. So it can be SolidWorks, CATIA, NX, or a similar program. So here we have a parasolid part that we are trying to import and perform a static case, a linear static analysis on this geometry, where these regions colored by green will be fixed. And then we apply like a force to see how this geometry behaves to the loading scenario. And then we also have a different geometry, which has similar attributes, the same attributes which the color data. And I will tell you why we use two geometries here and how it applies. So of course, so these workflows, what I'm showing here, uh, can be made as a template in my library. So what I can do is, so next time my colleague or my friends who would like to develop such workflows doesn't have to do from scratch always. So what I would do is I create it as a template like this, and then I can push it to the library. It's like a SharePoint where you can share files like PowerPoint, Excel, text files similar to that. You can share also the workflows. So here one can create different libraries based on the projects or the requirements, and then push these workflows there. So before I start building the FEM workflow, I had all my experts in the team who developed different workflows. So one for meshing, one for applying the material properties, the database, and one for setting up the boundary conditions, which is the pre-processing and things. So I will show you how we can make use of the knowledge of the team or engineers, and which is stored inside the software like this in the form of templates to build a workflow in few minutes. So as everybody knows, the first step and before we start in the FEM process is the mesh. So those who are not so into FEM simulation live here, so one has to mesh this given part. So what we can do is create different measures. In this case, one can also connect to different measures. Here we have Hypermesh as well. So synera itself is a low-code open platform. That means one can also connect various other softwares or solvers or technologies inside the platform. I will show in a bit later how it works. So here I have the measure from synera, our internal measure, and we will try to mesh this part. So of course, one has to define an element size to mesh this given part. So here comes my first template. So what I would do is I would make use of one of my team's knowledge to mesh this part. So here is the template. As you can see, there's like a icon on this node. It's a template. And here you can see where it's saved, Akhil's library. If I go inside this, it's the knowledge of my expert, meshing expert who created this workflow. This is as generic as possible and works for any geometry or any scenario or project. So I can reuse this multiple times. So here you see, all I have to input is a geometry and it will give us the element size based on different approaches. So let's try to give our geometry as input. As you see, the input, the connection is always these cables. So one has to connect the cables from left to right. And here we have different approaches my meshing expert has created. And based on the approach I select, we get a different element size. So for now, let's not go too much details into meshing and try to mesh this part. and give this as an input. So here you can see it starts meshing, and then here we have the mesh already in the viewer. Of course, one can refine the mesh as much as possible based on the results that we are looking at. And then, so let's go with this mesh for now. And of course, one has to apply, define a material to perform the simulation, right? So here, what we would do is define a solid property, which means assigning the material to this mesh. So here we have to define the mesh. So here comes my another template, which is select material. So this is created by my material expert, and there are certain materials which are pushed to my library. So based on the material I select, the properties would be output from this template. So of course, one can also push more materials. So if you go inside now, these are the different materials we have. And here you can push more materials. So if you click on plus, there is no limitation on how many materials one can create. So now I'm selecting aluminum to assign to this given part. And then, so we are good with the mesh and assigning the properties. So next step, what we have to do is assigning the boundary conditions. So as you observed, this given geometry has metadata. That means these color attributes. So this is like a communication between a CAD engineer and a simulation engineer, how one can assign the boundary conditions, which is force and fixed displacement. So there is also another template here. It's called boundary conditions. It's also created by my FE pre-processing expert. This is defining the boundary conditions, and this is to extract the regions for this boundary conditions is this one. So all we have to do is input the geometry, and based on this color attributes, it can also be name attributes or any metadata. It will extract the regions that's required for setting up the boundary conditions. So this is the output here. We just connect this boundary conditions region to the other template and select which direction the force has to be applied and what is the magnitude of force. So that was the boundary conditions. Here we have the mesh. All we have to do next is just construct the model, assemble everything, give the mesh assign with material, the load step. And then there's also multi-point constraint, which is RB here. Of course, one has to give a name here. So let's give like FE model. So that was quick to construct an FE model here. So all we did was made use of the knowledge of all my engineers to in different scenarios to create the mesh to determine what should be the element size, how one can extract the regions for setting up the boundary conditions, and so on. So here we have to solve the model now. And like I said, synera is an open platform. One can select between different state-of-the-art FE tools that you already have on that you're already using today. So here we have connection to ANSYS, Abacus, Nastran, OptiStruct from Altair, and we got our own Synera solver as well. So it's basically connecting the model itself to the solver, and then it will solve the model. So for example, if I use OptiStruct or Nastran, it's just the change of switch of cable from here to my to Nastran or OptiStruct. So that's just switch of cable, how one can switch between different solvers. Then let's visualize the result here. So that was the FEM workflow, linear static analysis in few minutes. So what we did is basically we made use of all the templates.
Really good. Okay. Regarding the integrations in the marketplace, maybe with the integration of CAD, CAE, and PLM tools, can you maybe show kind of how the marketplace looks like and what can people do with it?
Definitely. So this is our marketplace in Synera. It's similar to like an app store on Apple. So what would you do is basically you go on to the marketplace and the respective connector that you would like to use, and You just have to click on install, and then it pops up in the software, whatever that has been installed. For example, if I click install Abacus, it will be installed here. So it's basically a connector between this particular technology and Synera without having to manually program or create the scripts, which has to be robust and things like this. So the the connectors are quite different depending on the type of application. So it can go from additive manufacturing to FA simulation to casting to yeah to cost applications to things like this. So there are like three different types. Module is basically the whole technology embedded within this add-in. You don't have to install any other thing, just install this and then it goes to some of the lattice related applications. And connector is basically what we are talking about. It connects to your solvers.
Very nice. We have a couple of questions coming in. Akhil, maybe you can answer those. How does Synera address the shortage of simulation engineers in mechanical engineering? And how does it improve efficiency and innovating by democratizing FEA? Maybe that's two questions in one, but maybe you can answer that.
Yeah, definitely. In general, the simulation itself is a bit, I would say, most not complicated, but a topic where expert knowledge is required. Because when somebody has to perform a simulation on a given geometry on a new design to see how it behaves in real case scenario, it's actually quite some work to do some meshing, apply the boundary conditions, how it's behaved in real case scenario, and see how it displaces or the part behaves. So this whole knowledge usually it's only with few simulation engineers or numerical method experts. And with Synera, what we try to do is store this knowledge in the software in the form of templates, what I was showing here. So it's easy to document the knowledge and also to save the knowledge such that when the simulation engineer is not available or busy with other projects, as a CAD engineer or not so expert in simulation, I can directly make use of these templates. So today, live, I don't have to go to my FEM expert and ask them to perform simulation on this given part. So I just made use of these templates.
Yeah, this is really cool, especially if you have a bottleneck in the simulation department and you're a CAD engineer who wants to leverage the work. Really, really cool. Okay, thanks for showing this. I have one more question. How complex can you get with this approach? Can I also develop assemblies?
Yeah, definitely. One can also import assemblies and perform simulation on that as well. So it basically depends on what kind of analysis we are performing. It goes to implicit contact analysis. In such case, one can also do that. Basically trying to automate the process and connect the tools together. That's what we are trying to do.
Mhm. Someone was asking, what about contacts? It's very hard to get proper zones. Not sure what they mean with that, but maybe you can.
Yeah, we have something called as also contact definition here.
Mhm.
And similar to how we define the boundary conditions with this metadata, one can also define like a rule-based approach, like a logic to detect the contacts based on the geometry. So that makes it easy to perform also implicit contact analysis here in Synera.
Perfect. Okay. Could you please elaborate on how Synero overcomes the limitations of CAD-embedded FEA tools by providing designers with expert functions, ultimately enhancing design quality?
Yeah, definitely. So one is making use of these templates to develop the workflow from scratch, and on the other side, one can make use of also let's say this workflow that we just developed in a few minutes. One can create it as generic as possible, like I said here, and create like the inputs and outputs. One has to give as an input to perform the simulation. So what it basically does is it enables any engineer or any team member to run simulations on their own. It can be simulation or it can be also any other workflow. So I will show you how one can push this workflow into a simple web environment with an easy, intuitive user interface and just give some inputs to perform the simulation. So that's how one can empower other engineers in the team to run simulations on their own.
Really cool. And then the last question so far is how does Synera streamline workflows by resolving the challenge of diverse APIs in engineering software?
So basically, as I said, we are an open platform. Synera tries to also connect with various other environments. One, we have, let me show this, sorry. So we have like different APIs. So one can run your own C Sharp or Python scripts to connect to different programs. Or we also have something called as a web interface where one can connect on your own to any web application using their API. So for example, in the templates, I have like one simple example to connect to ChatGPT. So what I did was basically I made use of the API from ChatGPT and then connected it here in Synera using the simple notes how we develop the FEM process.
Mhm. This is super cool. And I've seen you already launched a Synera Run application. What is that all about?
So the whole workflow what we developed in FEM, I just pushed it to a web environment, which is here published to Synera Run. So following your previous question, Joseph, how so one can easily share this whole workflow for anyone who doesn't have to go through the details of the process itself, for example, FEM, but simply give certain inputs to perform the simulation for any part. So here it says import the part for which mechanical simulation has to be performed. So what I do is I select the file here and then select the material that we want to perform, the direction where the force has to be applied, in which the force has to be applied, and the amplitude itself. And then I just click on run. I don't have to install anything. So it runs all this process on the machine of this workflow developer, and I can easily share this link with anyone. So I can,
So cool.
this is across the team or an organization who doesn't have to install heavy applications or also perform, like, look at the results quickly, right? So that's the
Yeah,
major idea of this.
this is really cool. Yeah, and anyone who's interested in the workflow and just wants to try it out by themselves, feel free to reach out to Akil. I posted the link to his LinkedIn profile in the description, so you can get access to this and ask him for more information. Can I use the same FEM model for different solvers?
Definitely. We can also do that in Synera, like I said. So we have connection to some of these different solvers today. All we have to do is simply switch the cable from one solver to the other solver like this, and then it launches the solver in the background. It will automatically connect, find the solver on my laptop, or one can also give, if you have multiple versions of, let's say, OptiStruct installed or Nastran installed, you can give the solver path and it will, yeah, basically run
Perfect.
using that solver.
Perfect. That makes sense. Um, Someone was asking about a larger view of the demo screen. Yes, we'll upload it separately again on YouTube, and we can share again the workflow and everything that we've shared today with you. Regarding Sonora Run, so multiple people can use the same license, or does everyone need multiple licenses of the solver to run this interface? That's a good question.
So Synera Run is something installed on one server where all the licensing and this yeah, accessibility goes. So one has to simply install check the number of tokens. Synera run, works basically based on the number of tokens. So usually we suggest like the optimal number of tokens based on the user. So this is how it works. And then one can access either Synera Run or the Synera application. But yeah, if you have more questions, feel free to ping Joseph or me. We can send more info later.
Yeah, you can also ping me. That's true. And then I'm going to send you more information. I think what's also going to be relevant is there's going to be an expert panel hosted by Sonora on FE, especially for CAD designers, to kind of go through the workflow, building it from scratch. So you can learn it really hands-on from the experts in the session. All right. Did we miss anything else, Akil? Anything we might have missed?
So this whole workflow, whatever we've built, we can also, like I said, recycle or reuse it for different geometries. So what we can try to do is we have like different geometries here. I think we can concentrate. So how we can run a similar static analysis or FEM analysis on this part, I will just show you now. So this has been solved. All we have to do is switch the cables from one geometry to the other and just wait for it to run through. It's, as you can see, it's going through different process. So this is the major advantage, what I see at least when I develop a workflow and I save it so that I can use it for multiple paths or projects. So I don't have to do this manually every time because it's not fun going through the same old steps, which is, you know, not thinking much and then the boring thing. So that's
Yeah,
that makes it easy to recycle the workflows.
absolutely. This is really beautiful. There was one question I got, which is, can we simulate the mechanical behavior in fatigue using synera, or like the FE solver in this case?
The fatigue simulation, we don't have it today, but yeah, our product team is always working on improving various FA functionality and the other functionality of the software. But on the other side, what we have is something called as run external program. So this is like a generic application or a feature where you can run your own solver. Uh, and then you can give, let's say, the input deck or the input arguments to run fatigue to control the program using Synera. But why one has to do this through Synera instead of doing in their current approach is basically to automate and connect different domains, let's say optimization and yeah, CAD and simulation.
Got it. Okay. Two more questions, and I think we can wrap it up then. One more was, is there a DOE option available?
So one can also perform parametric optimization and design of experiments. I can show it here. So here we can set up the parameters and define what could be the yeah, input parameters one has to run. So let me show it here. So you can input different parameters and what has to be the outputs. And then based on that, one can perform design exploration, select how many experiments that you want to perform.
That was pretty fast, I have to say. It's super straightforward. And then the last question, Akil, for you is, the in-house Synera solver is included within the 14-day free trial. Is that correct?
That's right. Yeah, you will get access to all the features, including the whole marketplace for 2 weeks.
Really cool. All right. As I said, I put the link of everything that's relevant for this session, but also for Synera in the chat. If you have more questions, feel free to reach out to Akil or myself on LinkedIn, and then happy to help you guys out. This was the first session. I think there will be a lot more to come on topology optimization, DFAM, and all these kind of things. So stay tuned. And thank you so much, Akil, for joining us today. And maybe there will be a second and third and fourth part in the future.
Thank you, Jousef. It was fun.
Cheers, guys.